Selecting the appropriate wire size for a 100 amp feeder to a pole barn involves understanding and applying the relevant electrical codes. Table 310.16 provides ampacity ratings for conductors based on their insulation type and temperature rating, while Table 310.15b6 offers an exception under specific conditions. The primary reference for determining the correct wire size is Table 310.16. This table lists the allowable ampacities of insulated conductors rated up to and including 2000 volts. These are not more than 3 single conductors in a raceway or cable or earth directly buried, based on ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit. The ampacity values are provided for conductors with temperature ratings of 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. When selecting a wire size from Table 310.16, the first step is to determine the load current that the conductor will carry. In this case, the load current is 100 amps for the feeder to the pole barn. Next, determine the temperature rating of the conductor insulation. Common insulation types include THHN, THHW, and XHHW. Each type has a specific temperature rating, such as 75 degrees Celsius or 90 degrees Celsius. The lowest temperature rating of any connected termination, device, or conductor is what determines the ampacity to use. For example, if the terminations are only rated for 75 degrees Celsius, then the 75 degrees Celsius column in Table 310.16 must be used. For a 100 amp feeder, using the 75 degrees Celsius column, a number 3 copper conductor is typically required. This is because a number 3 copper conductor with a 75 degrees Celsius insulation rating has an ampacity of 100 amps, as per Table 310.16. Now, let's examine Table 310.15b6, which provides an exception to the general rules for dwelling unit feeders and service conductors. This table allows for the use of smaller conductors for specific feeder and service applications in dwelling units. The exception in Table 310.15b6 is applicable only under certain conditions. Firstly, the feeder must supply the entire load associated with a one-family dwelling unit or an individual dwelling unit in a multifamily dwelling. Secondly, the ampacity of the ungrounded conductors must not be less than 100 amps for a 100 amp service or feeder. Thirdly, the feeder or service conductors must terminate in a main breaker or fuse disconnect rated at the same amperage as the conductors. This exception is designed to reduce the conductor size for dwelling unit feeders and services where the load is unlikely to reach the full calculated load. This reduction is based on the understanding that dwelling units typically do not operate all appliances and devices simultaneously at the maximum rated current. However, this exception is subject to limitations and conditions, including the length of the feeder. In many cases, the exception in Table 310.15b6 is not applicable to feeders that extend outside the dwelling unit, such as those running to a detached garage or pole barn. This is because the table is specifically intended for dwelling unit feeders and services within the dwelling itself. Considering the specific scenario, the feeder runs 50 feet from the house to the pole barn. Since the feeder is not within the dwelling unit and runs to a separate structure, the exception in Table 310.15b6 does not apply. Therefore, the wire size must be determined based on Table 310.16. As previously mentioned, a number 3 copper conductor with a 75 degrees Celsius insulation rating is required for a 100 amp feeder, according to Table 310.16. Using a number 4 conductor, which has a lower ampacity rating than required, would violate electrical code and could pose a safety hazard. It is important to note that electrical codes are designed to ensure safety and prevent fire hazards. Using undersized conductors can cause them to overheat, leading to insulation damage and potentially causing a fire. Furthermore, voltage drop must be considered when selecting the wire size. Voltage drop is the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. To minimize voltage drop, it is important to select a wire size that is large enough to carry the load current without significant voltage loss. For a 50-foot feeder, voltage drop is less likely to be a major concern, but it should still be considered, especially if the load is sensitive to voltage variations. To calculate voltage drop, use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current resistance for the conductor material, I is the current in amps, D is the one-way distance in feet, and Cm is the circular mils of the conductor. For copper conductors, K is approximately 12.9 ohms per circular mil-foot. The circular mils for different conductor sizes can be found in electrical handbooks or online resources. After calculating the voltage drop, compare it to the recommended maximum voltage drop, which is typically 3% for feeders. If the calculated voltage drop exceeds the recommended limit, increase the wire size to reduce the voltage drop. In addition to wire size, the type of conduit or cable used for the feeder is also important. The conduit or cable must be suitable for the environment in which it is installed. For example, if the feeder is buried underground, it must be installed in a waterproof conduit or cable that is approved for direct burial. Common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. Each type has its own advantages and disadvantages in terms of cost, durability, and ease of installation. When selecting a conduit, consider the mechanical protection required, the resistance to corrosion, and the ease of pulling wires through the conduit. The number of conductors allowed in a conduit is also limited by electrical code. This limitation is based on the fill percentage of the conduit, which is the ratio of the total cross-sectional area of the conductors to the cross-sectional area of the conduit. The fill percentage must not exceed the maximum allowed by electrical code, which varies depending on the number of conductors and the type of conduit. To determine the correct conduit size, consult the tables in the electrical code that provide the allowable fill percentages for different conduit types and conductor combinations. Another important consideration is the grounding of the feeder. The feeder must be properly grounded to protect against electrical shock and to provide a path for fault current to flow back to the source. The grounding conductor must be sized according to electrical code, based on the size of the rounded conductors. The grounding conductor must be connected to a grounding electrode system, which typically consists of ground rods, ground plates, or metal underground water pipes. The grounding electrode system must have a resistance to ground that is less than 25 ohms. If the resistance is greater than 25 ohms, an additional grounding electrode is required. Surge protection is another important aspect of electrical safety. Surges are transient overvoltage events that can damage or destroy electronic equipment. Surges can be caused by lightning strikes, switching of electrical loads, or other disturbances on the power grid. To protect against surges, surge protective devices should be installed at the service entrance and at branch circuits that supply sensitive electronic equipment. Surge protective devices work by diverting the surge current to ground, thereby protecting the equipment from damage. The surge protective device must be rated for the voltage and current of the circuit it is protecting. Proper installation of the feeder is also critical. The feeder must be installed according to electrical code and manufacturer's instructions. This includes proper support of the conduit or cable, proper termination of the conductors, and proper grounding of the system. Incorrect installation can lead to safety hazards and equipment damage. When terminating the conductors, use appropriate connectors that are rated for the wire size and material. Make sure the connections are tight and secure to prevent overheating and arcing. Also, be sure to label all the circuits and equipment clearly so that they can be easily identified. Regular inspection and maintenance of the electrical system are also important. Inspect the wiring, connections, and equipment regularly for any signs of damage or wear. Replace any damaged or worn components immediately. Also, test the ground fault circuit interrupters and arc fault circuit interrupters periodically to ensure that they are functioning properly. If you are not familiar with electrical work, it is best to hire a qualified electrician to install or repair the feeder. Electrical work can be dangerous if not done properly. A qualified electrician has the knowledge, skills, and tools to perform the work safely and correctly. In summary, selecting the correct wire size for a 100 amp feeder to pole barn involves considering the load current, the temperature rating of the conductors, the length of the feeder, and the applicable electrical codes. Table 310.16 is the primary reference for determining the wire size, while Table 310.15b6 provides an exception that is not applicable in this case due to the feeder extending outside the dwelling unit. Voltage drop, conduit type, grounding, and surge protection are also important considerations. Always follow electrical codes and manufacturer's instructions, and hire a qualified electrician if you are not familiar with electrical work. Remember that electrical codes are designed to ensure safety and prevent fire hazards. Adhering to these codes is essential for protecting yourself, your family, and your property. Therefore, in this scenario, using a number 3 wire based on Table 310.16 is the correct and safe choice.